Welcome back. In this topic, we're continuing our discussion on Kubernetes CNI, but now we're shifting from managed Kubernetes to bare metal Kubernetes. If you look at the AWS console, you'll notice that there is no EKS cluster running. Instead, when we jump to the AWS EC2 console, you'll see a single EC2 instance. On this instance, I've pre-configured a single node bare metal Kubernetes cluster using Kube ADM. This cluster is running Calico as its CNI plugin. Besides the AWS CNI and Calico, there are a wide range of Kubernetes CNI plugins available. Let's roll into action by connecting to our node, which is acting as both the master and the worker node. I'll switch to the root user and clear the terminal to reduce clutter. Here, the kubectl get nodes command shows us the IP address of the worker node. Let's confirm that this IP address matches the EC2 instance itself by checking the interface IP using ifconfig. I'll quickly install the Linux NetTools package so this command is available. As expected, we can now see that the interface IP matches the Kubernetes worker node IP address. Before we break anything, let's first establish a baseline. Right now, the single node bare metal Kubernetes cluster is healthy, and Calico is running as the CNI. I'm going to deploy a simple pod and confirm that it comes up successfully. Currently, there are no pods in the default namespace. Running kubectl get pods against the kube system namespace shows our Calico CNI pods running. I'll now create an engine X pod named with -CNI. There's a typo in the image name. I'll delete the pod and recreate it. Here we see that the engine X pod with -CNI starts successfully, receives an IP address, and there's working networking. This shows us what normal operation looks like when the CNI is functioning correctly. Now that we've established the baseline, I'm going to deliberately break the Calico CNI. To install the Calico CNI, I followed the official Calico documentation, but intentionally used a lower Calico version to match the Kubernetes version running on this cluster. Installing and removing the plugin is straightforward. We use kubectl apply to install Calico and kubectl delete to remove it. Before deleting the CNI, let's first remove our engine X pod. Now, let's delete Calico by running a kubectl delete command directly against the Calico manifest file from the Git repository. If we look in the kube-system namespace, you can see that the Calico pod is now entering a terminating state. I'll now redeploy the exact same engine X pod again with the Calico now in a terminating state. Running the kubectl get pods command, we can see our pod named without dash. CNI is stuck in the container creating state. Running the same command once more, we can see nothing has changed. The pod is still in the container creating state. At this point, I want to see why the pod isn't starting, so let's inspect it more closely. I'll run a kubectl describe pod command against the without CNI pod to view the underlying events and errors. Right away, we see the key message, failed to set up network for sandbox. If you remember, this is the exact same error we encountered earlier when we deliberately broke the AWS VPN CNI. This tells us something very important. Whether we're running cloud-managed Kubernetes or bare metal Kubernetes, CNI failures present themselves in the same way. Now, if I run kubectl get pods -w, we can clearly see that we're stuck here. The pod will not progress past container creating because networking cannot be initialized. At this point, the fix should already be clear. Let's restore networking by reinstalling the Calico CNI from the manifest. I'll apply the Calico manifest now. While that's running, I'll quickly check the pod status again. And as expected, it's still in container creating state, while the CNI components are coming back online. Now let me switch to the kube system namespace and verify that the Calico pods are running again. Everything looks healthy. Calico is back. Let's return to our Nginx pod and check its status one more time. And just like that, we're back in business. The pod is now running successfully. I hope this demo gave you a clear and practical lesson in how to troubleshoot and recover from CNI failures in Kubernetes. So one day, when an adventurous junior engineer accidentally deletes CNI pods in your cluster, you won't panic. You'll know exactly where to look and how to fix it.